Gradient descent. Gradient descent is an algorithm that optimizes parameters by reducing cost function. Notice: parameters are coefficients and the intercept. Today we want to learn how gradient descent optimizes parameters. For example, suppose we have this dataset. Each feature has effects on the outcome. We consider that effect as coefficient. So our equation would be like this. There is a coefficient for each feature and there is a noise number named intercept. And the h of x is our outcome, here being amount of sales. So we have to find this parameters for predicting the amount of sales. For start, we set random numbers for parameters. For example 1. And put our first instance in the equation and predict sales. The difference between predicted value and the actual value is called error. So we have to reduce the error. In other words, we have to reduce the cost function j of theta. Power and division are for simplicity of later calculations. So we calculated the cost function. Now we should update parameters with this equation. In this equation we have to take the derivative of the cost function j of theta with respect to theta and multiply it by alpha. Alpha is learning rate. So what is learning rate? Look at this picture. Learning rate is something like steps in reducing the cost function and reach the minimum. If our learning rate is too high, we may pass the minimum, and if it is too low, it takes time to reach the minimum. So it shouldn't be too low or too high. Notice: scikit-learn gradient descent algorithm automatically picks a good learning rate. So we took the first step. We took the derivative and updated parameters, but they are not optimum yet. So we put our second instance in h of x, but this time with our updated parameters. And do whatever we said again and again until our derivative gets close to 0. Note: as you can see in the graph, when derivative gets close to 0 we have reached the minimum. Then the algorithm finds out our parameters are optimum. We have three main types of gradient descent: stochastic gradient descent, batch gradient descent, and mini-batch gradient descent. In stochastic gradient descent, instead of using every single instance, we use some random instances for optimization. This is useful when we have a large dataset and want to reduce the time complexity. In batch gradient descent, dataset splits to batches. After all instances in the batch are evaluated, the parameters get updated and go to next batch. This algorithm is a bit more accurate than stochastic gradient descent because it uses the entire dataset, but it's not suggested for large datasets because it has more calculating and a bit slower than stochastic gradient descent. Mini-batch gradient descent is something in middle. It uses a random batch of instances and optimizes the parameters, and do this again until parameters are optimal. However, our dataset is not that large, but in this video we implement stochastic gradient descent. We implement other types in next videos. Now we want to implement stochastic gradient descent in Python. But before that, please like this video and subscribe to our channel. This is our dataset in CSV file. We import pandas library as PD. With pandas we read the CSV file and put it in df. The input is x and output is y. So we put feature columns in x. Feature columns are entire columns except sales. And we put sales column in y. Now we want to split dataset to train and test parts. So we import train test split from scikit-learn model selection. Just like before, we split data to 4 parts. X train X test, Y train Y test. We set test size 0.1 and random state 12. Test size is the ratio of test to train size and we put it 1/10. We assign some number to random state so it doesn't produce different parts every time we run the program. Note: We should scale our numbers before put them in gradient descent algorithm. It performs better on scaled data. So we import standard scalar from sklearn preprocessing. We put standard scalar function in scalar so we can use its inner functions. Then we fit and transform xtrain and xtest. Notice, we just scale input parts like xtrain and xtest. Now we import stochastic gradient descent regressor as sged regressor and put it in algo. Then we fit train parts to the algo. Now we can predict xtest output and put it in ypred. The xtest exact output is in ytest. And the predicted values are in ypred. So we import a metric to compare and give a score. From sklearn metrics we import our 2 score and give it the ytest and ypred and print the score. Now we can run the program. But it seems like we have error. I forgot to write the CSV. But there's also another error. I have written ytrain and xtest displaced. Run the program again. You can see the output. We have a good accuracy. In next videos we implement other types of gradient descent. Thanks for watching us and don't forget to subscribe.